let's do another example of using the second derivative test. Again, recall that the idea when you're looking for relative maxima or relative minima of a function, you first look for critical points. A critical point is where the first derivative is either 0 or undefined. So you take the first derivative, set it equal to 0, and figure out where it's going to be undefined. And then you take, and among the points that you found there are going to be all the x values for relative extrema. Then you have to sort through those critical points to determine if they actually are a relative max or relative min. And so the second derivative test allows us to decide whether a critical point where the first derivative is 0, it's important that it's not where we don't have the critical points where the first derivative is undefined. It doesn't work for those. Where the first derivative is 0 allows us to decide whether those are indeed, those critical points locate relative extrema or not. So let's look at this function. F of x is e to the x minus x. And so we first of all want to look for critical points. So the first thing we do is find the critical points. So we'll take the first derivative. So let's see, f prime of x, if f of x is e to the x minus x, f prime of x is e to the x minus 1. Derivative of e to the x is e to the x. Derivative of x is 1. So we have that. And now we'd have to set this equal to 0. All right, it's never undefined because, of course, 1 is never undefined, and e to the x is never undefined. So, all right, we'll set e to the x minus 1 equal to 0. So then e to the x is equal to 1. Now, if this were a more difficult problem to figure out what x would be, to take the natural log of each side. And let me do that just to demonstrate it, although this one's pretty easy to see, I hope anyway. Notice, remember that the x comes out, so we have x times the natural log of I forgot to take the natural log of 1. I have to take the natural log of both sides. X times natural log of e is the natural log of 1, which is 0, and the natural log of e is 1, so we have x times 1 is equal to 0, x is equal to 0. And of course, we knew that if we raise e to the 0 power, we get 1. So x equals 0 is a critical value. So since f prime of x is equal to 0, x equals 0 is a critical point. All right. In fact, it's also a stationary. Remember, stationary points are those critical points where the first derivative is 0. Now, does it locate a relative maximum or a relative minimum? Well, let's check and see. All right, we can use the second derivative test. Since this is a stationary point, we can try the second derivative test. Well, the first derivative was e to the x minus 1. The second derivative is going to be the derivative of e to the x is e to the x, and the derivative of 1 is 0. So the second derivative is going to be just e to the x. Now, if I evaluate e to the this second derivative at 0, at this stationary point, at this stationary value, or the critical point, all right, I get e to the 0, which is 1, and that's, of course, positive. It's greater than 0. So what's going on here? I have, at this point, at x equals 0, I have a horizontal tangent line, because the first derivative is 0, and I have the second derivative being positive, so the graph is opening upward, so we have a relative minimum. Okay, let's take a look. I have this all worked out. So notice here at x is equal to 0, the first derivative was 0, we had a stationary point. The second derivative was positive, we're opening upward, so we have a relative minimum. The minimum value that we have there at 0 is 1. So f of 0 equals 1 is a relative minimum of f, okay, I believe, of f of x, which is equal to e to the x minus x, okay? Question. So there we have a second example of using the second derivative tests.